The Milky Way, home to billions of stars, rising and setting over billions of worlds, including our own. In this vast expanse, how did our sun, the Earth, and the planets come to be? In recent decades, our understanding of the solar system's evolution has greatly improved, but deep questions remain. To answer those questions, astronomers are preparing to visit someplace very small. Asteroid Bennu. A lump of rock and organic material, the early building blocks of the solar system, of Earth, of us. Bennu is a time capsule, and its journey takes us way, way back, 4.5 billion years. The raw ingredients of Bennu and our solar system originated in a stellar nursery, a vast cloud of hydrogen, helium, and dust. Our own sun doesn't yet exist. Nearby are hot stars like this one, quickly burning up its fuel and destroying itself in a colossal explosion called a supernova. The explosion destabilizes our cloud, causing it to collapse. In the geologic blink of an eye, 100,000 years, gravity and angular momentum flatten the cloud into a swirling disk. In the center, where molecules crash together tightest, a protostar revs up to incredible pressures and temperatures. Deep within the disk, clumps of dust not much larger than a grain of wheat are flash heated into droplets of molten rock, called chondrules. The source of this heat remains a mystery. Chondrules are destined to become the building blocks of the solar system. Coaxed by gravity and turbulence, the chondrules clump. They grow into the first asteroids, into mountains, into planets. The asteroids are rubble piles of rock, metal, ice, and organics. This large asteroid is the parent body of Bennu, a protoplanet whose size we can only guess. Closer to the protostar, a planet begins to form, and then dawn in the solar system. The protostar undergoes fusion and ignites, revealing our sun. But the solar system is far from finished. Jupiter most likely forms near its outer edge, but just 500 million years after the sun ignites, some believe that it slowly moves inward. Its massive gravity ripples the asteroid belt, disrupting countless asteroids and comets, flinging them toward the sun. They rain down on the inner planets, hammering and remelting large portions of their crust. Did these impacts also deliver organics and water, key ingredients for life? Back in the asteroid belt, Bennu's parent body is lucky. It survives this period of heavy bombardment. The solar system cools and calms. Jupiter and its many moons assume the orbits that we see today. Billions of years of quiet follow, more or less. Then 1 billion years ago, one theory suggests a collision shatters the protoplanet. Some of the debris loosely coalesces into a new, smaller body, Bennu. But Bennu will not stay in place. Dull, non-reflective, it slowly migrates toward the sun. Solar heating turns its warm side into a low-intensity thruster. Through millions of years, Bennu's orbit gradually tightens until it interacts with Saturn's gravity, altering its trajectory and hurling it into the inner solar system. Close encounters with Earth and Venus follow. Their gravitational tugs may have repeatedly stretched and reformed Bennu, turning it inside out and pulling off loose material. As a result, it has no satellites of its own. Until now. Today, NASA is sending a spacecraft called osiris-rex to explore Bennu and retrieve a sample. Why? Bennu has survived its long journey and settled into a near-Earth orbit, bringing its secrets within our reach. Now it is ready to teach us more about the solar system's history, its formation, its evolution, and our own place among the stars.
In 2018, as NASA's osiris-rex spacecraft neared its target, Bennu, the asteroid grew in detail from a few tiny pixels to an incredibly high-resolution image. Osiris-rex confirmed the asteroid's basic shape, which was originally observed in 1999 by ground-based radar at Arecibo Observatory. What scientists didn't expect was just how rough and boulder-filled the asteroid would turn out to be. While it can be difficult to fully grasp Bennu's unfamiliar surface, it's helpful to understand the scale of what you're seeing here. In this image, the brightest boulder is the length of a horse, and the large boulder in this image is the width of a soccer field. Another challenge for the mission is the asteroid's small size and weak gravity. This means that osiris-rex needs to fly daringly close to the surface in order to enter into orbit. With its orbital A phase, osiris-rex successfully entered the closest ever orbit for a spacecraft, setting a Guinness World Record in the process. Then, 6 months later, it beat its own record during its orbital B phase and approached to within a few hundred meters of the rocky surface. Because osiris-rex flew so closely over the surface during orbital B, the team was able to map the topography and shape of Bennu better than we have our own moon. In addition to mapping asteroid Bennu, osiris-rex plans to collect and return a sample back to Earth. To do that, the spacecraft will carefully tag the surface of Bennu. The osiris-rex team has selected 4 possible sample sites for the mission: Osprey, Kingfisher, Nightingale, and Sandpiper. The spacecraft has been closely imaging these sites from different angles to select the best touchdown spot for osiris-rex. What was originally envisioned as a smooth and easy touchdown on Bennu's surface has become a complex endeavor to tag a small, crowded space on the asteroid, an area no larger than a few parking spots, by mid-2020. The osiris-rex team has already pushed the boundaries of scientific exploration, going from ground-based radar images all the way to being a few hundred meters from the asteroid's surface, and is now mere months away from a sample collection attempt.